This video is about IB past paper about trig equations. For 1a, show that sin 2x plus cosine 2x minus 1 equals 2 sin x cosine x minus sin x. First of all, this is a double angle identities in the formula chart. Sin 2 theta equals 2 sin theta cosine theta. Cosine 2 theta equals cosine square theta minus sine square theta equals 2 cosine square theta minus 1 equals 1 minus 2 sine square theta. Remember, for cosine 2 theta, we have two twisted form. 1 plus cosine 2 theta equals 2 cosine square theta. And 1 minus cosine 2 theta, 2 sine square theta. Also, we need to remember 1 plus or minus sine 2 theta equals cosine theta plus or minus sine theta square. Therefore, for 1a, sine 2x plus cosine 2x minus 1 equals sine 2x. We got to use this formula. You will get 2 sine x cosine x. For cosine 2x minus 1, we got to use this formula. Opposite of 1 minus cosine 2 theta will be negative 2 sine square theta. So for cosine 2x minus 1 will be negative 2 sine square x. Simplify, we have 2 sine x cosine x minus 2 sine square x. Common factor will be 2 sine x. So we have cosine x minus sine x. Finish proving for 1a. For 1b, hence or otherwise, solve sin 2x plus cosine x minus 1 plus cosine x minus sin x equals 0. For x is greater than negative pi, less than 3 pi. So we have sin 2x plus cosine 2x minus 1 plus cosine x minus sin x equals 0. These three will be 2 sin x cosine x minus sin x, then plus cosine x minus sin x equals 0. Then for these expressions, we have a common factor is cosine x minus sin x. So we take cosine x minus sin x, you will get 2 sin x plus 1 equals 0. Since these two factors equal 0, we will set up cosine x minus sin x equals 0, or 2 sin x plus 1 equals 0. We will solve these two separately. For first equation, move sin x to the right side. You will get cosine x equals sin x. Then we divide it by cosine x both sides. You will get 1 equals tangent x. For second equation, you will get sin x equals negative 1 over 2. We know the domain x greater than negative pi less than 3 pi. Before we draw the diagram, let's decide the quadrants. Sin x equals negative 1 over 2. Negative sign will be in the third and fourth quadrant. Reference angle is 30 degrees. That equals pi over 6. For tangent x equals 1, 1 is positive. Positive tangent is in the first and third quadrant. Reference angle equals 45 degrees. That is pi over 4. So we only need to write down the pattern for third, fourth, and first quadrant. The domain given is between negative pi and 3 pi. Let's draw the positive first. This is 0, pi, 2 pi, 3 pi. So we get started from this 0. Stop at 3 pi. Then let's draw negative. Go this way. So we have a negative pi. We stop at negative pi here. This is the first, second, third, and fourth quadrant. For the first quadrant, we have a pi over n and 2n plus 1 pi over n. For fourth quadrant, we have negative pi over n and 2n minus 1 pi over n. For third quadrant, you have a n plus 1 pi over n and a negative n plus 1 pi over n. For tangent x equals 1, first and then the third quadrant, we know this n equals 4. So we plug into this pattern, first and then the third quadrant pattern. You will get x equals pi over 4, 9 pi over 4, 5 pi over 4, and negative 3 pi over 4. For sin x equals negative 1 over 2, we know n equals 6. In the third and then the fourth quadrant, we can write down the solution. X equals negative pi over 6, 11 pi over 6, 7 pi over 6, and negative 5 pi over 6. Altogether, we have 8 solutions to this equation. Let's go to number 2. Show that the equation 2 cosine square x plus 5 sin x equals 4 may be written in the form 2 sin square x minus 5 sin x plus 2 equals 0. For 2a, we have 2 cosine square x plus 5 sin x equals 4. We will move this 4 to the left side. So we get 2 cosine square x plus 5 sin x minus 4 equals 0. Then for this cosine square x, we will change into 1 minus sin square x. Therefore, you will have 2 times 1 minus sin square x plus 5 sin x minus 4 equals 0. Distributive property, you have 2 minus 2 sin square x plus 5 sin x minus 4 equals 0. Combine like terms, negative 2 sin square x plus 5 sin x minus 2 equals 0. Then we divide it by negative 1 both sides. You will get 2 sin square x minus 5 sin x plus 2 equals 0. So we finish proof for 2a. Let's go to 2b. Hence, solve the equation 2 cosine square x plus 5 sine x equals 4. X greater than equal to 0, less than equal to 4 pi. From 2a, we can change 2 cosine square x plus 5 sine x equals 4 into 2 sine square x minus 5 sine x plus 2 equals 0. Nature x, we have 4, negative 5 over 2 over 2. For this 4, the factor, the pair is 1, 4. Adding is a 5, but we need a negative 5, so we change the sign. Negative 1, negative 4 will be the factor, the pair. Then reduce, you will get negative 2, 1. The variable is a sine x. Sine x. Bottom up, we will write down the factor like this. 2 sine x minus 1. Sine x minus 2 equals 0. So you get 2 sine x minus 1 equals 0, or sine x minus 2 equals 0. Negative 2 moves to the right side. You have sine x equals 2. No solution. Because the range of sine x is a closed interval from negative 1 to 1. For the first equation, isolate the sine x. You will get 1 over 2. Since 1 over 2 is a positive, so go to the first and a second quadrant. Reference angle is a 30 degree, that is pi over 6. Let's draw the diagram. Because domain is between 0 and 4 pi, so you have 0 pi, 2 pi, 3 pi, and 4 pi. Get started from this 0, ending at 4 pi. The quadrant we are looking for is the first and a second quadrant. Therefore, we have a pi over n, 2n plus 1 pi over n. No 4 pi, because 4 pi stop at the fourth quadrant. For second quadrant, we have n minus 1 pi over n, 3n minus 1 pi over n. Therefore, x equals n equals 6. So we have 5 pi over 6, 17 pi over 6, pi over 6, 13 pi over 6. We have 4 solutions to this equation.